Hello again, everyone. Now, this is a slightly odd video. For some of you, this is going to be the start of creating Objo, our object-orientated language that we're building using Zojo to learn how to make a programming language. For some of you, it's going to be the second. Now, that's because I made a video, I had a video where we started to create the Tokeniser, which is the first part of building a programming language essentially, which is taking the source code and splitting it into tokens that we can then manipulate and do something with further down in the pipeline. Now, the last video, we got about a third of the way through making the Tokeniser, and then I had to take a few weeks off broadcasting because I was on holiday, which was lovely, but I couldn't make any videos, and so I still had my laptop, and so I pushed on and finished the Tokeniser. Now, I noticed a few errors and bugs and problems, and rather than trying to pick up from where we left off, I'm going to remake the video. It'll still be a couple of videos. I'm going to split it because there's still a lot to cover in the Tokeniser. All the methods, etc., are the same, so you could, in theory, probably skip the first video and go to the second video if you already watched the last one. Essentially, this is just a reboot of making the Tokeniser, and I do apologize, but I think it will be more slick and will be quicker and will be better for it. So without any further ado, we're going to start making the Tokeniser properly now. So first things first, we would normally just create a project for Objo that we would start building in Zojo, but I've already started the project and finished the Tokeniser, or at least a first crack at the Tokeniser. And so that I've pushed it to GitHub. Now I have a video on using GitHub and GitHub Desktop with Zojo, which I'll try to remember to put a link in the description. It's really useful if you were to watch that, because that will help you, because Git is absolutely fantastic and everyone who's a Zojo programmer should be using it. Because we need to pull down the repo which stores the Zojo code that I've written so far for Objo, and not only do we need that, but I also have another repo which this will depend on that we'll need to pull down, and I'm going to show you how to do that now. So get Git set up on your computer following my video. Then what we're going to do is we're going to go to my GitHub page, which is github.com/gkjpettit, and /objo is the Objo repo. And I'm going to go code, open with GitHub Desktop, and I'm going to clone it to somewhere on my hard drive. Done. Okay, if I find that file, it's here in my repos folder, Objo. Here's the repo I've created. And what we want is we want to go to source, desktop test harness, because this is the project we're going to be testing it in. And then it's this project here. That's what we're going to double click and run, but we're not going to run it just yet because it'll become apparent shortly, but we're going to be manipulating strings an awful lot in this project. And I've got a module which I call StringKit, which is open source, which has a bunch of useful methods in for handling strings that don't come built in with Zojo, which is also open source. And you'll need to pull that down as well, because that module is used by our Tokeniser, and I've included it as an external class, or rather an external module. And again, I have a video on that which you can watch, and I'll put a description, a link in the description to it for you. So the next thing we need to do is we need to pull that repo down as well. Okay, otherwise what will happen is if we try and load it, try and load what we just pulled down from GitHub, what will happen is it's going to say, hey, where's StringKit, which is the name of the module. It doesn't know where it is. So we're going to cancel that. We're going to get some errors. Okay, we're going to, yep, errors, all bad, quit. We need to pull down StringKit. Now the URL for that, again, it is on GitHub. It's gkjpettit/StringKit. Link will be in the description. And we'll pull that down, open it with GitHub Desktop, choose allow, clone it. Okay, boom. Now we've got everything we need, because if we go to our repos, here is StringKit, okay, and here's all the tools it includes. This is the file, basically, that the Objo project needs. Now, depending on where you've cloned string kit to in relation to Objo, it all just might work for you when we load the project in a second, or it might say, where's string kit? This is the file you need to point it to, okay? Right, so let's go back to Zojo and let's open up the Objo test harness. And hooray, it comes up. And you can see here is string kit. It's a module, it's got a little arrow because it's an external reference. And you'll see I've got a whole bunch of methods for checking if something's properly uppercase, whether it's Latin, whether it's an ASCII character, etc. So it just was easier to reuse some code I already have. It's boring code to write. So now we've got the project set up, we need to get started. So how I've decided to structure this project is I've got a top level folder called Objo. And in that, I'm going to keep all my Objo classes that I need for the Tokeniser. Now, because I like to keep all of my methods and classes as external to my project, you can tell they're external because they have this little black arrow. I prefix them with either some letters like an acronym or a word. So I've prefixed everything to do with Objo with the word Objo. So we've got 3 classes here in a module. We've got Objo token, Tokeniser, Tokeniser exception, and then I have a module which I've called Objo as well. And that's going to contain methods which are sort of global to the Tokeniser and also to the parser and the compiler, which we'll build later. And I've put them all in a Objo folder to keep them neat and tidy in the navigator. So let's just make sure we're all on the same page when it comes to what a Tokeniser is. So a Tokeniser takes our source code, which is essentially a string, so a string of characters, and it splits the string into characters, and it analyzes them one by one sequentially, and it tries to build what are called tokens. Now, tokens are like the basic atomic unit of a programming language. So they're things like keywords, integers, string literals, binaries, operators like plus, equals, divide. These are all tokens, and that's what we want the Tokeniser to do. We want it to take a string and spit out an array of token objects. So of course we need a class to represent a token, which I've called Objo token. Now it's got a few properties. It will have a lexeme, which is a string representing the actual characters that make up that token. Let's say we have the number 150. It will be that will be a number token, but its lexeme will be 150, the string 150. We want to know that for many things we need to know the value of the token. We don't actually need to know the value for some tokens, so we don't need to know the value of the keyword add handler or the keyword then. It doesn't matter, we just know it's the keyword. We just know it's the then keyword. We don't actually care about the characters, but the class will be able to store that. We also have an integer to store the line number, which will be 1 based, that the token is found on in the source code, and the start position, which is the zero based position in the source code that the token begins at. And finally, I've got an enumeration here called type. You can see over here, it's of type token types. That's what the enumeration is called, and it's in the Objo module. So we go in the Objo module, enumerations, and we've got token types. And here you can see a whole list of the different tokens that Objo, the language, recognizes. So we've got binary literals, left parenthesis, any keywords I've prefixed with keyword. So we've got keyword break, keyword for, keyword if. We've got identifiers, all sorts, all the different tokens that we're going to have to chop up the source code into, stored as enumerations. And that's it, that's all the token needs to store. We've got one method, which is just a constructor, which will take all of those properties as part of the constructor, and an optional lexeme. So like I said, sometimes a token doesn't need to care about the lexeme. So that's our token class done. Okay, that's the basic atomic unit that our tokenizer is going to split the source code into. I've created a simple class which is called a tokenizer exception, and essentially it's just a subclass of runtime exception, and it just means that later on in the pipeline, if something, when we're trying to handle errors in the user's code, it's nice to have separate exceptions for the different parts of the pipeline. So we're going to have an exception that's raised if something goes wrong during tokenization that we can catch later on. And there's nothing special about this. It's just, other than it inherits all the properties that runtime exception does. And we've got 3 integer properties. One is the line number that the exception occurred on. One is the character position in the line. So if you think about it, well, actually, let's look at absolute start position first. It's easy to understand. This is the absolute position in the source code of the first letter of the token that caused the problem. And that is helpful, I suppose, and we need to know that. But actually, what you might want to do is say to the user, hey, an error occurred on line 17 at character position 4. Okay, not character position 4 in the whole source, but character position 4 on the line, and that's what the line character position will store. And finally, we've got the tokenizer itself. Now, this is where the real magic is going to happen. The tokenizer is the class that will take the source code as a string and return an array of tokens. We've got a whole bunch of methods here that we're going to have to work through, but the main one is this Tokenize method. And like I said, it takes a string and returns an array of Objo tokens. Okay, so this is what we're working to. So where do we start? Well, I guess let's start with the tokenizer. So we don't have a constructor. So what we do have is a few properties though that we need to keep track of. We've got a string array called cars for characters. And what that will do is that will store, when we get the source code that we need to tokenize, we will split it into characters and we will store each of those characters. We have a pointer, well, not a pointer is the wrong word, I don't want to confuse you. We have an integer which remembers where in the source code array, so when we split the source code into characters, where in the cars array that we're currently analyzing, okay, which character we're looking at. We keep track of which line number we're on at the moment. As we move through the characters, we will keep track of, are we on line 7, are we on line 8? We also, I think for making error messages a bit easier, when we start the tokenization process, we not only split the source code into characters, but we also split it into lines. And that will, the utility of that will become apparent a little bit later. We keep a reference to the source. Why not? Okay, keep it around. We're going to keep an internal array of tokens. These are the ones that we've made so far, but we haven't yet returned. And we also keep a record of the zero-based position that the current token that we're building starts at in the source code. So that's what the tokenizer needs to remember. So let's start with the first method, which all kicks it off, the tokenizer. And in fact, we'll show how this will work. And let's just add an event to, actually no. What will happen is we will create an instance of a tokenizer, and then we will call this Tokenize method and pass it the source code we want to split into tokens, and we'll get back an array of Objo tokens. Now, how do we do that? Well, first of all, because we might use the tokenizer many times, we need to make sure we reset everything back to how it should be. So I've got a method here called reset, which isn't difficult. It basically just resets everything to defaults that I like, clears out the cars, lines, and tokens arrays, and resets everything to an appropriate default. We keep a reference to the source. Yes, before we do that, we've got the source code. Now, because Objo is cross-platform, and specifically because it runs on Mac OS and Windows, we need to handle line endings in a funny way, because line endings are different on macOS and Linux and Windows. On macOS and Linux, it's actually one Unicode character. I think it's Unicode character 0A is the end of line character. Whereas on Windows, it's 2 characters. I think it's the line feed and the carriage return characters together. Now, since we're working through the source code 1 character at a time, that's going to mess stuff up if we don't standardize that or handle that case. So what we do is when we first get the source code, S, we use the built-in function replace line endings that is part of the Objo framework to replace any line ending with the Unix line ending. Okay, we could have chosen the Windows one. It doesn't really matter. I mean, it makes sense to use the Unix one because it's just 1 character, so that's what I've chosen to do. So then we'll have a source code that if it has any new lines in, the new lines will always be Unix ones. We're going to keep a reference to the source code so we can refer back to it later if we need to. And then we're going to split the source into individual characters with s.split and then a blank string. That will just give us an array of every single character, including new lines. And as I said, we're going to split the string also into lines, splitting on the end of line character. And that's going to be useful for error messages later on. And then we just enter a loop. We just say we need to keep on getting tokens until we've eaten up, consumed all of the source code. So I've got a loop that says do next token until we reached end of file. Obviously, we've got to implement these things. So the first thing to look at is reached EOF, reached end of file. What is that? How does that work? Let's take a look at it. Basically, what we do is we return true if we've got to the end of the source code. So the first thing we do is we check, do we have at least 1 token? Because our tokenizer will always finish its tokenization process unless there was an error by including a special token called EOF, end of file, and that will signal to the parser later on that you're done. Okay, so there will always be at least 1 token if things have been okay and if it has reached end of file. So make sure there's at least 1, and then we look at the last token in our tokens array. We check its type. If it's the end of file token, we're done. If not, we're not finished yet. And then we have this next token method, which we're going to look at now. And obviously when we've reached end of file, we just return the array. So next token, what makes that up? Well, we're just going to do this first bit here with whitespace, and then we're going to break, okay, because there's going to be a lot to take in. I don't want to overwhelm you. So the next token, first thing it does is it says, okay, the current pointer starts at 0, okay, cars 0, okay, it points to the first character in our array of characters. And then we will update that as we move through the string. So when we're going to get a new token, we want to remember, well, where did it start? Okay, so we store in token start the value of the current pointer. The next thing we need to do is meaningless whitespace. Well, is meaningless. Okay, it doesn't have any meaning to the parser, so we need to ignore it. We don't want to have tokens representing spaces or tabs and stuff, which has no meaning to the parser but will confuse it. So we need to strip those out. And so I've got a method here called skip whitespace, which does just that. And we'll take a look at that. So what it does is, first of all, it enters a loop. Okay, it's going to analyze the current character, and it's going to say, well, what it's first going to do is it's going to enter a loop, and then we will select peak. Now, peak is a method that looks at the current character and returns it, but it doesn't advance the pointer. It just sort of peeks at what's coming up, okay, but doesn't actually move past it. And we can take a quick look at peak. It's very simple. Basically, what it says is, if the current pointer is less than or equal to the last index of the character array, then return it. Otherwise, return an empty string. Okay, empty string represents essentially that we're basically at the end of the source code. So if when it peaks, if it's an empty string, we're at the end of the source code. So we can exit out of this skip whitespace loop because we must have skipped all the whitespace. If it comes across a space or a tab, then we want to move one character forwards. Okay, we've seen a space, we don't care about it, let's go forwards. And to do that, we use a method that I've created called advance. Now, advance is basically the same as peak, except it will also increment the current counter. And that has the effect of returning the character, sort of peaking, and then moving forwards one character. And we'll have a quick look at the code. As you can see, we increment the current pointer, and then we return the previous character. Now this is going to assume that you're not at the end of the character array. We have checks elsewhere, because otherwise this is going to give you an out of bounds exception. But we don't want to keep checking for out of bounds every single time we advance a character because it will slow our tokenizer down. And we have to put call advance here because we don't care about the character that it returns. We would just want the method to do its thing. We don't actually care about the value returned because we know it's going to be a space or a tab. If it returns a /, then it could be a comment because comments in Objo start with 2 /, just like they do in Zojo. Objo, I've decided, isn't going to have an apostrophe comment or the rem comment. I don't use them and I can't be bothered to support them. It seems pointless. But so if we peek and we see the character coming up as a /, we need to know, is the next one also a /? Because if it is, then basically we need to gobble up the comment. So I've got another method here called peek next, which is basically like peek, except it's one past the current. Okay, exactly the same code as peek. So if we have got 2 / in a row, then we're basically in a comment and we need to consume it. We need to move past every single character thereafter until we get to the end of the line. And to do that, I have a method which is called consume comment. And this is pretty straightforward. It enters a loop. It peeks at the next character and says, if it's the end of line, then okay, we've got to the end of the comment because we've reached the end of a line. A new line, that signifies the end of a comment in Objo. So what we do is I have a method which says to add a token. What token? Well, we need to make a token. So I have another method called make token of type end of line. And we're going to come back to these methods in just a moment, but essentially we were adding an end of line token, increment the line number because we've reached a new line character, exit the loop and we're done. Otherwise, if we don't see the end of a line, but we're at the end of the source code, so at end is a method, and all that does is say, hey, has the current pointer gone past the number of characters? If we're at the end, then that's also the end of the comment because we've reached into the source code, so we exit. Otherwise, we call advance again. We just keep moving forwards through the characters. So what are these make token and add token methods? Now these will grow in complexity, but essentially if we go to the make token method, what this does is it just returns a new token and of the type that we specify. Okay, that's the parameters passed, and it says it started at token start, which remember we update in next token, and it also adds the current line number. So it's a convenience method for us. It basically just makes a token without a lexeme. Okay, so use for tokens without lexeme, because remember the constructor for an Objo token takes an optional lexeme. So it's just a very convenient method to say, hey, make a token of this type that started at token type, at token start, and on the current line number. An add token is pretty straightforward, but we have a special case that we need to handle. So rather than just append to our tokens array a token that we've created, which we could do, we don't want to, there's two things we don't want to happen. If someone puts lots and lots of returns like this, okay, in their code, we don't want a whole bunch of end of line tokens, because that's just going to confuse our parser later on. So we do two things. Firstly, we don't let the first character, the first token that the tokenizer makes, be an end of line character. Okay, so if the source code started like this, we don't care about any of this. This is essentially meaningless. Okay, so we don't let that happen by basically saying, hey, if there are no tokens and the token is an end of line one that we're trying to add, don't add it. Otherwise, if you're trying to add an end of line token and the last one, the last token was an end of line, then bail. Okay, then just return. That will mean that we will never have more than one end of line token in a row. Otherwise, we just add the token to the array. We just append it. Okay. So that's consume comment. Where were we? Skipping whitespace. Okay, so we can handle the end of the line, sorry, the end of the source code, spaces and horizontal tabs, and the start of a comment we can handle. The next thing we need to handle is the end of line character. So when we hit a return, that's very important in Objo and Objo because it signifies the end of a statement. Now, Objo, like Zojo, supports the concept of an underscore. So in Zojo, you probably know that you can have if true and false, right? It's a pointless little if statement. You can split over multiple lines by putting an underscore and then return. Okay, and this will be counted as one line. And we want to support that in Objo because it's helpful. So when we're skipping whitespace and we come across a new line, we want to see, hey, was the last token that was added elsewhere in our tokenizer? And we will get to that in the next video. If the last token was an underscore, then what we need to do is we need to get rid of that underscore and don't add an end of line token. And that will have the effect of, to the parser, that underscore and new line never happened and that the two lines are contiguous. So that's quite easy to do actually. What we do is we check that we're not on the first token and we check that the last token added, if it was an underscore, then we pop it off. Okay, we get rid of the underscore. We advance past the new line character and we increment the line number because we've hit a new line. Otherwise, if we hit the end of a line and the last token wasn't an underscore, then all we do is we add an end of line character, sorry, add an end of line token, we move past it and we increment the line number. Otherwise, if we hit any other character, so not whitespace, not a comment, not an end of line, we exit. Okay, we're done. All right, so we've skipped the whitespace. So we'll come back here. Oh, I'm sorry. We go back to next token. So we've skipped over it. Now we need a little check here. We need to make sure that there isn't just a whole bunch of whitespace before the end of the source code. So we need to do a check to make sure we haven't got to the end here. So if we have got to the end of the source code at this point, then we add an end of line token because we always need to terminate a statement with an end of line. And we know that the add token method won't let us add an end of line character if we've already got one before, so we don't have to worry about checking for that. And we add our special end of file token to signify, hey, we're at the end of the source code, we're done. And then we return. Otherwise, we need to analyze this character, okay? So we know where this token is going to start. We've skipped over uses whitespace, and we've done a little check to make sure we're not at the end of the source code, and we're now about to evaluate the next character. Okay, so we need to get it as a string by calling advance, which we've already covered in skipping whitespace, but we just get the next character from the array that we're pointing at. So I'm going to stop here. It's a nice tidy 30 minutes. The next video, which will come very shortly, we will carry on. This is the point that we got to in the last video. Okay, so you're all caught up now, and we will next start tackling literals, numbers and strings and other things. Thanks for watching.